Okay, so what we're going to do now is on page 287, problem 414 in the blue book. So in the blue book, you're going to turn to page 287, and we're going to enter this chart into our calculator. However, we're going to put length of cavity into list 1, and we're going to put the heart weight into list 2, and then we're going to graph the scatter plot. So if you can do that. But this is list 1, this is list 2. Make sure you have all your data cleared out for me. Okay, so now what we're going to do is we're going to look at the scatter plot. Okay, so the scatter plot looks like it could be exponential, but it also doesn't look like it's increasing by that same ratio, right? Like yesterday when we looked at it, it was beautiful. So power models, so we're going to talk about a power model now. Power models can look like an exponential model, and sometimes power models do better predicting than exponentials. So we have to decide what we need to do. So on the AP exam, what they might do is they might give you a residual plot. They might give you the original data and then 2 other graphs and ask you which one is doing better. So remember, our whole goal is we recognize this is nonlinear data, so we can't use the least squares regression line. But what can we do to this data in order to linearize it for us to get an equation that we can use? Okay, so I don't want you guys to think about, oh my gosh, I'm going to have to remember all this. We're just going to practice, okay? Because this isn't really going to happen. So I want you to go into Stat, Edit, and this time I want you to go up to list 3. So I'm showing you what the calculator is doing so you understand. And I want you to hit log, and then I want you to hit second L1. So you're telling your calculator, hey, can you please take the log of list 1? Okay? And then we're going to go to list 4. Okay, and we're going to do the same thing, but this time we're going to take the logs of the response variable. Where an exponential model, if it's increasing, only took the logarithms of one of the response variable. So I'm going to do log, and I'm going to do list 2. So if this was an exponential model, okay, exponentials only take the logarithms of the response variable. A power model is going to take the logarithms of both. So now what we're going to do is I want you to go back and let's look at that scatter plot now. So in our scatter plot, my original data was in list 1 and list 2. Now my new data is in list 3, list 4. So what I expect to see now is not that curve shape. What I expect to see now is a line. That's what I'm hoping to see. Because if I see a line, then I know that I did the right model. Zoom 9. It's not perfect, but it's a line, right? Okay. Some people ask me, well, what if I did the logarithms of just the response and I got a line? That's fine. It probably will happen because this one looked very similar to an exponential model. So if it comes down to that, right, they give you a power model and an exponential model. What you're going to look at is you're going to look at that correlation, and you're going to decide based on the correlation which one has a better correlation. The one with the better correlation is the model you pick. So I'm telling you right now, for this one, our model, right, is better as a power model, okay? So now what we're going to do is we're going to come up with that equation. You and